So hello and welcome to the HackerNoon Podcast. This is Utsav Jaiswal, HackerNoon's blockchain editor. And today I have the team from Freeton. These are the guys with the claims of being the fastest blockchain in the world. As of today, it's 63,000 transactions per second. And representing the team, I have Benjamin Bateman, who is one of my favorite podcasters, hands down. I might be biased, but that's where I am like coming from. Check it out if you guys haven't. It's fun. He is also the community's busybody, a self-acclaimed busybody, although he's very nice to speak to. And I also have Mitja Goroshevsky, I'm sorry. And he is the CTO at Ton Labs, and he has been leading the development team that has led to this breakthrough.
HackerNoon Podcast.
Without further ado, I'd like to pass the mic back to Mitja and tell us about what he has been doing since the inception of the Ton blockchain and how it evolved into something that is now called the Freeton.
Yeah, thanks. Just to start about the evolution of the Ton, just to get past that point, really. And it goes like that. So there was a Ton project by Telegram, which got sued by SEC for like alleged, getting money from investors and launching a blockchain. I don't know. So SEC thought it's a security or something, despite the fact that it was the security exemption and there were lawyers around Telegram. All this shit, which never prevented anyone to be sued by SEC, as we all know. So on certain point in this lawsuit, we, meaning the community, which was formed around Ton at that time, like Ton Labs was doing 3 years of research about Ton technology, based on like papers from Telegram, and there were community people who were doing projects around Ton like for several months at that point. And we have participated in this in drafting some responses to SEC as a community. Like I led the draft of the response to their technical experts and so on and so forth. And we had a lawyer who helped us just navigate through this process, like Dima Joffe, was a great guy, great friend. And on a certain point, we realized that it's not going to end good. It's just not going to happen. The SEC would never allow the original Ton to launch
because of the shit, right?
Because of all that kind of shit.
Blockchain, man.
Because of what really? It's just because of the money that Telegram raised and not in a proper way by what SEC is thinking or were thinking. And but we said, then the community said, we don't have anything to do with this money. We didn't raise any money. We didn't participate in any ICOs or anything like that. So whatever SEC is doing with Ton, why it should affect us? Why SEC doesn't sue us? I mean, right? So so we started kind of to discuss that within the community, what we want to do, and we only disagreed on the way to do that. Basically, but there were forming several groups that wanted to launch it, and we said okay, we disagree on the way to launch it, but we want to launch it, and that was the consensus. And then I have drafted the first declaration of decentralization text, and then people joined in to draft on top of that, and there was a community building around that idea of launching Freeton. And some validators brought other validators from different networks, like Peer-to-Peer.org, like Kostya Lemashuk brought some people from Cosmos community, and so on and so forth. So, and they all said you're probably doing right thing. It's interesting. After we launched, even Vitalik actually said, in tweets that it's very interesting experimenting decentralization, right? Because so what is the project or the founders got sued by SEC, but there is an open source code and we can use that. And there were people who developed on top of that some other open source code. So who would prevent us from launching? Right, so that's how Freeton was launched, and that is like became kind of a center of research around on technology, and which then evolved into what we have now. Like I published a version, like a draft of white paper of Freeton several weeks ago. It's publicly available now. And it's open for comments. There will be a final version, like probably coming out in like days or whatever. But and it describes like the evolution of the technology and how far we got from the original kind of research that Telegram did, which was really like an MVP level research. And what we primarily like the research that was going inside Ton Labs, and the result of that research, as you all know right now, like brought to this results that we have today. So that's more or less the evolution.
Got it. And I remember speaking to you earlier when you were like mentioning about proof of finality. I found it to be quite fascinating, like when you mentioned that in the case of rollups, like because the proof of finality happens way down the line, there can be events where after 28 days of the transaction being done, you get the notification that it has been rolled back. And now you don't actually have the money. And on the Freeton blockchain, the proof of finality is pretty fast. It's in the seconds, if I'm not wrong. You guys have a 63,000 like TPS that has been calculated. So how do you like get there? What is the kind of expertise that you need? Why couldn't Ethereum do it? Like, why is the Bitcoin at like 7 transactions per second? Why is like the newer blockchains the ones that are building it, when the biggest case that these Ethereums of the world have is that they have the most developers? If they have the most developers, why aren't they faster, in your opinion?
Sure. Well, there are several questions in one that you composed.
Of course.
So I will
Sorry.
Yeah, I will start from the end. Like, why many developers can't build something that a small team can? Well,
Right.
you have that answer every week or something when a big company acquiring some startup, right? So it doesn't prevent, like the Apple has like, or Google has tens of thousands of engineers, maybe 100,000 engineers. And then they come startup with 5 engineers, which does like something that Google couldn't build.
Right.
It's happening all the time. And I even don't want to answer that. I mean, it's kind of a law of innovation, right? Innovator's Dilemma, great book by Christensen, like you can read it, right? So why big corporations cannot innovate? What prevents them from innovating? So like Ethereum is of course, as any other established project is like in a way subject to its own problems, like its own heritage, if you want, like, right? So the Ethereum cannot move as fast. Ethereum cannot change design as fast. Ethereum engineering kind of execution, because of the way they do the engineering, is very limited, meaning that they cannot produce results in time. And we know that it's already a kind of a community joke, right? Around that. So, and we have an engineering competition going on, right? It's why Intel produced like the best processor at time, right? Why the X386 architecture is the winning architecture today and not some other? Because they're like PowerPC, for example, like because there were kind of a competition of engineering, great engineers here and there, and someone won. That's as simple as that, right? So their design was like their design requirements probably were put correct way. The balance of the engineering, compromises that you make all the time in engineering, of course, was like just the correct compromises, and someone did the incorrect compromises. Someone thought that something is more important than the other, and in the end, it apparently is not important at all. It is just these things. It's just a law of evolution of engineering. So. So I think this is the answer why, like, I cannot, and probably we had the right design, and we had the right design because we from the beginning thought, again, we started late in a way. Like if you think about when, like, probably the point of time when you can do decisions are important, and the lack of heritage that you have. Like if you have a community which expects certain things from you versus the community that don't expect anything from you, except for, like, for example, results. And you say, like, we want to build the fastest blockchain. Ethereum never said we wanted to build the fastest blockchain. So how they would do that? Like, if you even don't put it as a goal, like, how it will end up being the fastest blockchain? Like, it's impossible. And there are only, I think, 3 teams in the world who actually said we wanted to be the fastest blockchain. Right? And these 3 teams are Solana, Near, and us. If you think of all the other projects, like, they put something else. Like Cardano, when they wanted to build their blockchain, like, their goal was to build, like, the most scientifically correct, I don't know, correct by construction, whatever,
peer-reviewed,
blah, blah, blah. Yeah. And the fact that finality in Cardano is 30 seconds is just like, what did you expect? Right? So when the projects like Cardano was putting their requirements, what they had in mind was like 13 seconds of Ethereum or like 10 minutes of Bitcoin, right? We want to build something with the smart contract capabilities, but less than Bitcoin finality. Well, that's a goal, and what you get is 30 seconds finality, right? Well, our goal was to build the finality which is comparable to when you hit the Facebook page and reload. As you can see, this is quite different kind of goal definition.
Exactly.
And in that goal, in that goal definition, your design choices will be quite differently made, right? You cannot anymore have like best fork choice, finality, blah blah blah, simply because it will take you enormous amount of time. Like it will take you seconds and seconds on top, and you just cannot have that choice. You need another.
Got it.
You need to think how you do that, right? And that's it. And of course, it's not something impossible to do. But if you think about scalability, if you think about fast finality and scalability, and you also say my constraint, because my constraint was always we want to be layer 1 blockchain, meaning I don't agree. Well, what happened? Why we have layer 2 idea? Well, we have layer 2 idea, not because it's the greatest idea of all times, not at all. Like this is probably one of the worst ideas of all time. Right. But this is the only way for the Ethereum to somehow tackle that problem of the gas price, of the throughput, and so on and so forth. Like they cannot do it otherwise because they don't have this blockchain on layer 1 that capable of doing that. It's not that they want to have layer 2. Nobody in the right mind wants to have a layer 2 solution or layer 2, layer 3, layer 4, whatever. When you stop. Right.
Sorry, can I make an analogy which will maybe show my age a bit? I don't know if anybody ever used to own a Mega Drive back in the day with the cartridge machines, the Mega Drive 2 game systems. But when all the game systems were moving towards CD-ROMs because of the increased memory capacity, Mega Drive released something called the 32X, which was supposed to be a revolution. And it was like a CD-ROM drive which had a cartridge slot in the bottom, which you would slot into your old Mega Drive to make your Mega Drive then run CD-ROM games. And this, to me, is very analogous with layer 2 solutions. I mean, just wait for the PlayStation, guys. You know?
Exactly. Very nice analogy. Right. Yeah. So, and then the whole logic, then it becomes like this. We have this huge community. We have this blockchain, which sucks as a design. Then we stuck on top, right? There's all these solutions that patches these holes in the problem. And we are fine. Well, no, you are not. Because in the end, like the best processor will win in the design, period. We are in the technology, guys, space. We are not in some kind of, this is technology. In technology, like the best technology wins, period. It might take some time. If there is not sustainable there are some companies who died on the way to bring the best technology to the market. Yes, that happened a lot. Like you have the best technology, but you die because you don't have enough resources to put it to the market. But if you do have it, if you do have resources, if you do have a sustainable kind of, like business-wise, in their respect and our respect, like the community with the Freeton community with it should be sustainable, of course, to bring this to the market. And yeah, it will take some time. But in the end, I just don't see, I just don't see how that can lose, frankly speaking. Yeah, I do believe in that design. And I never said that bluntly like that before, because I always want, I want to talk like an engineer and not like a marketing guy.
Clearly.
And when you and when you say, when you ask marketing guys, and they always say, oh, we have the fastest blockchain, and they have the fastest, and these guys has the fastest, and whatever blockchain they have, right? And then I always okay, so show me some results and show me some technical stuff. So show me what you can show. And so before we could show, really, I didn't want to come here or anywhere and say we have the best technology, best design. Now I can, and that's why I pressed this. This is completely useless exercise what we did, right? And it took 6 months and about $2 million to do that. It's insanely stupid. But if you think about that, it's what Elon Musk was doing when they put this unmanned rockets and then breaking it up in the atmosphere and the stratosphere, and then trying to land them back in these motors on the on the boats. Motors on the useless motor on the boat. This is an exercise that probably they spent billions of dollars doing that. Yeah, why did they do that, right? Because in the end, if you want a NASA contract, you need to show that you can actually do that.
Right.
Yeah, so I wanted to show, our goal was to show to the world that this design really wins. I mean, it really wins. It can scale. And now we have these results. We can prove that it scales. We can prove that actually now, of course, and it's not the end, 62, whatever, 45 on the open internet, 45K, it was a TPS on the distributed data centers. But the point is not that. The point is that it can scale even further or any further you want. We can, because we worked with a configuration of 20 work chains, which would be 20 chains and 32 threads. Basically, so think of that as a processor design. Think of the threads and the cores of the processor. So we had 10 cores, 32 threads each, and we can actually configure this process to run on 100 cores. It just scales. Of course, there are some limits to the internet capacity, blah blah blah, but in reality, the traffic that we are producing is I don't know, maybe 5 to 10 times less than, for example, Solana traffic on one chain. And it's just laws of physics. You cannot go around that.
Right.
You can, whatever you do, you cannot do that otherwise. It's very simple. Guys, that's it.
Totally understandable.
I don't know.
I'll have to bring in Ben into this, right?
I was going to say, to jump in with another analogy, it's a very basic one, not quite as good as my Mega Drive analogy, but it's very much like building houses, building blockchains, isn't it? So again, Ethereum can't do what Freedom does because it has, the foundations that Ethereum laid all those years back. It has this base and it has to grow out of it. Whereas, like Mitja says, at the minute, the 64,000 per transactions per second is just essentially what has been built on top of the foundations as a proof of construct. Using this design, like Mitja says, the actual scale of how tall the blockchain can get with this is, it's pretty inconceivable by today's standards, I think.
Right. I was thinking of this byline while Mitja was speaking. Was building the fastest blockchain was the stupidest thing that I did.
Well, the thing is, but believe it or
you can tell he's not a marketing guy, can't you?
Yeah, exactly. Or maybe
I spent 6 months doing this. It was stupid.
Well,
no, you didn't say that really.
Believe me or not, but the point about fastest part is less interesting about Freedom design in my perspective. This is the flashy thing. This is going to stratosphere thing. But in fact, much more fascinating things are in the in the what we call tone operating system design, in programming languages, kind of innovation stuff, in the what we call distributed programming. Like distributed programming for me is way more important innovation in the blockchain design than multi-threading and multi-sharding. Because it allows you to create really distributed smart contracts, and not the smart contracts that you built right now on Ethereum. Because if you think, and I just give you an example of 10 seconds example, because I know that probably not everyone is programmer here. So in Ethereum, if you want to build a token contract, you create a huge, basically map. Think of that as an Excel table. I don't know. And in this table, you put someone's wallet address or public key versus amount of tokens they have. And of course, as you can understand, Excel table on your local computer cannot scale up to more than whatever.
Agreed. 10,000 and up, it starts to crash.
Yeah, exactly.
Yeah.
So that's exactly the thing that happened and to Ethereum smart contracts, which are using hash maps and so on. It's just not scalable. And if you think about the whole design of the blockchain, from the perspective of it being a database, you put tables inside the tables. You put databases inside the cell of a database. It's bad design. You don't. If you think of that as a design of a database, then from the database design standpoint, it really sucks. You don't build databases like this. And if you want to program like that, it's really bad programming. It's really not, not scalable. It leads to all kinds of some core contracts unbalanced, basically thing. You have unbalanced.
So how did we get over here? How did we end up over here? Some of the smartest people on the world.
It's very simple because it's very simple because it's a naive design. It's what you do when you have. Okay. Well, it's just naive. You and it's fine for the first iteration of this system. It's totally fine. Now, how do we do that? We just stack it there, and that's it. It works. We stack a table. We stack a table hash map in the block, and it works. Right? What's the problem? Right? It really worked for years. It works now, even right. Yeah, it's kind of bad design. It's kind of not scalable. But then we will think about something. Right. But the problem is that you cannot really think about something. You need another database. And that's why we have many databases today, right, in database space. Because there's someone comes with a better design optimized for something timescale databases and some other stuff that are optimized for certain things. Right? And it's totally fine. The problem here is that, again, you have a huge community around the blockchain that, doesn't scale, doesn't produce enough, fast finality times, has this layers on layers as a patches, and then also has this bad programming kind of habit or concept. Right? So, a lot of people using that. For sure.
They have to, because
exactly.
Ethereum smart contract, easiest to write, right? If I am somebody who is new and I find out, okay, Solidity has all of these frameworks. If I need to create an ERC20 token, I just need to change 3 numbers on one line, right? Exactly. Why would I go anywhere else? But that brings me to this marketing question. I want to pass it on to Ben, because he is a better marketer for Freeton than you are, which I'll be very honest. So how do you position Freeton as? Every blockchain that you see out there has some value proposition, right? Bitcoin, decentralized gold, or let's say internet money, magic money, Ethereum, supercomputer, Solana, I don't know, Polkadot, parachains, Tendermint or Cosmos. How do you what is that one word that you would want to use for Freeton?
Well, I'll be honest with you. I mean, I came on board with Ton Labs, the company behind Freeton, of launching it, obviously, a little bit later than some of the other guys through, the big June Network merger and acquisition process. And I mean, I racked my brain for quite a long time on this question, specifically, if Bitcoin is digital gold, then what is Freeton? And the problem is that no one can actually, in the same way, like no one officially ever titled Bitcoin digital gold, it sort of evolved into this moniker with time and usage. And to try and actually brand Freeton or to try and give it some label or moniker, the more we tried to push that, everyone gets to decide what Freeton is and what it's for. We can't get the community to use any one logo. We can't get, we can't have one centralized website. That's not the way decentralization works, unfortunately. So, we can try and push in certain directions, but I mean, to give my own personal opinion, what Freeton really is it's decentralized opportunity. Ethereum, put in place and again, I'm not a programmer, but, the Turing complete programming side of things. So it moved digital cryptocurrency and blockchain past just transactions side of things. It added all these if-else statements. What Freeton does is, again, it opens that gateway of possibilities into the realms of, if Ethereum was the equivalent of the Turing machine, then Freeton is going to be the equivalent of, IBM or, Windows. It's an operating system. It can do things that, well, no other blockchain will be able to do. And conceivably right now, most of us probably haven't even thought what it will be doing in 5 years, 10 years from now. Like, you just got to look at the partnerships we're working with, and I'm sure Mitja could tell you much more about this than me, but personally, I'm very, very excited about the work World Chess are doing using the blockchain. We've got Human Ventures who are doing some really exciting and damn it, I tried so hard to say that word first time. So some charitable work, to say. But yeah, the stuff Human Venture are doing, which I'm a part of, and we recently just received the UK Innovation Grant to forward this here in my country, is mind-blowing, in this kind of real-time finality. Freeton it's unparalleled, I think, and I'm not a programmer, I'm not a dev, I'm a user. So when I came to Freeton, I'd been in crypto a few years, but I'd never used a bloody multi-sig wallet. I'd never created my own coin. I'd never interacted directly with smart contracts to do X, Y, and Z. And the learning curve isn't that, it's all interface friendly. It's user friendly. It's built from the ground up, without that naivety of not really knowing where the whole industry is going. Like Mitja said, when Ethereum was built, it was an experiment. No one knew what Ethereum. If anyone ever said to Vitalik, hey, build this thing, Ethereum, and then in about 3, 4, 5 years' time, we're going to all use it to launch these crazy tokens and launch businesses and ICOs out of nowhere, and you're going to be responsible for this crazy boom. You'd have gone, well, that wasn't what I was trying to build. Sorry, guys. Sorry, very long answer to a short question. If you were just looking for digital this, but no, it's decentralized opportunity as I see it. Like I say, there's never been an ICO. Anyone can come get involved, like I did. I'm a plonker, and I'm heavily involved, and yeah.
For those of the people who are not in Britain, what does the word plonker mean?
Just someone who isn't ashamed to say they're a bit of an idiot, or I'm very open with my shortcomings. I know what I know, and I don't know anything else. That's
Gotcha. Let's get back to Mitja on one-line answers, right? It could be a very fun exercise. Mitja, I will give you a name of a blockchain, and you have to tell me how is the Freeton blockchain different from it. Are you up for it?
Sure.
Right? Let's start with the very simple one, Bitcoin.
Well, the Bitcoin doesn't have the extensive smart contract capabilities, of course, and it's very slow, and it's proof of work, and it has a UTXO a model instead of a counting model. So there are it's very hard to say what it is different. Because it's different in everything, more or less. There are less similarities. Like you have blocks, and that's about it.
Gotcha. And I'll go
some record into the block.
Yeah. And I'll go right to the other end. What is the difference between Freeton and Polkadot?
Well, Polkadot is a multi-chain design like Freeton. We have work chains, they have parachains, but all the rest is pretty much different because it's not a homogeneous system. It has it now patches the design to allow for things that Freeton has from the beginning, for example, like inter-blockchain messages and stuff like that. It also doesn't have the same the system is completely kind of, you want to launch it's like a private blockchain which like the parachain is like kind of private blockchain which just have some guarantees to the whatever beacon chain, or I don't remember how they call it.
Beacon chain.
No, not beacon chain. There's Ethereum. Yeah, right. I don't remember what's the name for the
relay chain.
Relay chain. Right. Relay chain.
Thank you, Pavel.
Sorry. Thanks, Pavel. Yeah. So and because of that, and this design was not. I don't think it was. Again, done for the same reasons like we did, and of course they don't have multi-threading. So it's quite naive, I think, approach and architecture to the problem of scalability and multi-chain kind of solution to scalability. Now, what would you do if you wanted to create just a multi-chain solution for the scalability and that's it? Well, you could do something like Polkadot, but it's just not enough. It's not a good design if you think about all the aspects that we spoke before about. Right?
Gotcha.
And it's not end to it's also not end to end. Like again,
it's not end to end. What does that mean?
It means that it still relies on Web3, for example. And Web3 by itself is a problematic approach to the user interface and to the blockchain. Because Web3 is actually another layer, because it brings the web as a layer to the interaction between the user and the blockchain. For example, so it's just a solution to a very particular problem of scalability in this way, and quite naive. So I think if you look at the Freeton design is way more kind of complete end-to-end and kind of thought through from the standpoints of all the requirements that we expect from like distributed operating system of today. It just I cannot put it more, I don't know, in a short version.
Gotcha. No, that was quite interesting, right? Because the points that you bring up are what like, as you also rightly said, were architectural differences. I basically skimmed over what Polkadot is in some of these blogs, and most of their parachains like Moonbeam or Plasm, their claim to fame is that we allow you to bring your Ethereum smart contracts or EVM. EVM support is like what they basically said they have. Is that worth it? Like, if that's your claim, then why are people going to use it? You brought these points up very wonderfully. Like, probably these are the things that the developers need to take care of. The next blockchain that I want to go over is a bit out there, Avalanche.
Yeah, well, Avalanche is interesting one, but their claims is just, it's a gossip-based blockchain, basically.
What does that mean? Explain that to us, please.
Well, the gossip is just a sort of protocol, a group of protocols where one node said something to another node said something to a third node, and that's a kind of gossip goes around the network until everyone reaches the consensus. And the Avalanche is using like this this funny algorithm about the coloring the response. I don't want to go into that. It doesn't matter. You can read about that. But the point of that is that Avalanche claims certain things like numbers that are just not, how to put it? Well, I would go with this claim, but yeah, it's like not.
You can probably be a little more sensitive than I was in my post. I didn't myself any Avalanche fans when I wrote about them, to be honest. So,
right. Well, it just, from my perspective, like you cannot go against the laws of physics again. And if you rely on gossip, we have a broadcast protocol, which is like almost a gossip protocol. We know exactly the propagation times and the problems it has with in terms of like propagation times and so on and so forth. Mm-hmm. So reaching consensus with this, with acceptable finality and kind of acceptable guarantees, I would say, is problematic. And I just don't think that, well, I'm not just don't think, we actually did some counting, right, Pasha? I think Pavel was actually doing that, like on Avalanche numbers and approach, and our numbers shows, yeah.
It's not about numbers. I mean, Avalanche is a different architecture. It's not blockchain. It is directed a cyclic graph, which means that your transaction can be reverted. So different nodes can think that your node recorded it wrongly, and then you can see that when you get some information about transaction recorded on one node, that record will be changed sometime in the future. The funny part about that design is that imagine you submitted like 1,000 conflicting transactions. We have $1, and you sent that $1 to 1,000 different accounts, and each transaction is fine. I mean, you sign it properly with your key, and you sent those transactions to 1,000 nodes in Avalanche. Mm-hmm. And all those nodes will process and record those transactions as valid because they are valid. What happens then? I mean,
is that for real?
Yes, for real, because this is a design of not blockchain, architecture. What they claim that, but at some point when those transactions, or let's say not those transactions, but when subsequent transactions will be propagated over different nodes, they will somehow decide where's the majority of. So there will be at some point, the majority of nodes will think what transaction is correct. But what if all nodes in that chain have recorded different transactions? Mm-hmm. How they can find what is the majority? How the 1,001st node should decide which of those 1,000 transactions it get is correct?
That's not possible.
That's a very interesting question.
That's not possible.
Yes, that's the point. The funny story is that this is exactly why Solana has its protocol called proof of history, because that is exactly what they are proving, which transactions was collated the first. Mm-hmm. So they solve the problem of conflicting transactions sent to different nodes and collated by different nodes. Mm-hmm. That's what they solved. But the problem with that is that they solve problem which do not exist. That's the funniest part about the design, because they prove history and they can sort transactions, but because they thought how to improve Bitcoin. But if you solve a different problem, as Mitja said in the beginning, you do not have that problem in the beginning, mm-hmm. because if you do not mix those transactions, which means you can allow only one node to collate a transaction related to specific count, then you don't need to sort it later on.
Then is it not centralization?
No, it's not about centralization. It's actually about the agreement on something, right?
Yes.
Okay.
Because you don't have a mechanism on agreement. You do have a mechanism on agreement, but this mechanism of agreement is kind of laid down in time, and then you have another problem, which is a problem of time. But if you have a design where you have you solve this problem from the beginning, you don't have it actually. Right. If you have for example, if you have a BFT consensus solves this problem because it chooses the leader, which collates the block, which basically proposes the transaction to the rest of the nodes. If you don't have it, then you have a problem of this synchronization between the nodes, which takes time.
So Solana did good job compared to BFT, because in BFT you can have like one block in 5 seconds, and Solana with sorting, with having that mechanism how to sort transactions, have 2 blocks per second, but they still have that potential conflicting transactions and blocks to sort. And in our work chain, we don't have that conflict from the beginning. That's why we can have 100 blocks per second, 100, not 200. In one work chain, and we can have many work chains working in parallel. So you see the difference.
Gotcha. But I would also want you to make it easier to understand for those who have no idea what you just said.
Oh, I think that's my job. I think that's where I step in with another bad analogy.
No, please do that, right? What I want you to do, like Ben, Pavel, I'm sorry. Go for it.
Go on, Pavel first.
Yeah.
Oh, yeah. I have analogy. Sorry.
Yeah.
Let's go with yours. Yes.
Sorry, but I think I have the best analogy.
Sure.
You know, Cinderella, they sorting. Different type of grain. But,
right.
And Cinderella can say, "I'm the best in the world in sorting that type of grains." But
agreed.
Before are doing it, she just mixing those grains. So just don't do it. I mean, don't mix those types of grains.
I like that.
And then you don't need, and then you don't need to
imagine you have sorted grains. Yeah,
right.
Then you put it all in one place and started to sort it again. Like, why do you do that?
She does that because she wants to. Exactly. She does that to show that she is the best in the world, right?
Yeah, she needs a party trick. Everyone has a party trick, don't they? Look at all these grains I can source.
Exactly. But
yeah, I like your analogy better than mine, Pavel. So you win that one, buddy.
But what I want to know for the people not in the know is that, let's say I have a Torn crystal and I want to send it to Ben. I have a Torn surf wallet. Ben has one too. What happens as soon as I hit the send button? Where does my Torn crystal get processed, and where does that end up at? The reason why I ask this is that maybe at least few people in my standing now know what happens with my Bitcoin when I send it. It goes to a mempool. There is some consensus, proof of work, and then it ends up with the UTXOs or whatnot. How does it happen on Freeton? Because your consensus is different. You have work chains, which basically makes things faster and scalable. So break it down for us from this perspective. Nobody knows how that works out.
Yeah,
help us out.
No problem. So you send a message, if you use external message, you send a message to a smart contract, because in Freeton everything is smart contract, and you send a message. I will explain.
So basically, what I'm trying to ask is,
it's a full node. Yeah.
Let's go with yours first. Okay, I will not interrupt you. Yeah, please.
Yeah. So the full node, which gets your external message, is transmitting this external message to the work chain, which processes your address. And from that work chain, actually goes to the thread that processes your address, because your address, which is the namespace of the contract in the blockchain, it's sliced, sharded towards a particular set of validators. And we can calculate these validators where they are. So you send the message to these validators, and these validators then between themselves, they run a BFT algorithm, consensus algorithm, but that's not the point. So they run a BFT, so they know who the leader, who collator is. So the collator, which collates the blocks, get this message, and it puts it in the block. And now the BFT consensus starts to work, and they agree on this block, and then they send this block to the master chain. But the thing is that in parallel to that, and that is what is explained in in the current white paper, and it's not at all in the original Tron design, is that this block candidates is also propagates to the network, to all the work chain, not the whole network, but to the work chain. That's important. And then there are some funny algorithms of choosing a verifiers, which basically, because in the work chain, every validator has the same data. They don't process the same data, but they have it. So the multi-threading is the following. So you have like all the nodes, all the validators in the work chain has the same data, but they only process transactions for a certain subset of accounts on that data. Right? And within this processing, like you have a BFT, but then also there are some other nodes, not in the BFT consensus, which verifies that actually the block is correct. And they send proofs of this to the master chain validators. Now, because of this, actually, you can have a finality which is faster than you don't need actually to wait until the block is confirmed in the master chain block. Think of that if think of that in I don't know, Polkadot chain. You have a parachain consensus, you have a parachain block, and you have a parachain transaction, but you don't need to wait until that finalizes into the relay chain.
Right.
You basically because of this consensus algorithm, which is a mix of several consensus algorithms, actually, you can rely on certain assumptions of correctness within the work chain itself, and say, okay, I'm fine. This transaction is final. It actually, because we are proving in a white paper, and I think there will be a separate paper on that this consensus enhanced BFT, or think of that as like two consensuses in one, provides the security guarantees which are more than that of a Bitcoin, actually. You don't even need to wait until the whole consensus part, because the collator, which collates the block, has so low probability of cheating that it actually will never, because his ability of cheating is so low, like probability of him to go unpunished for the transaction, for the wrong transaction in the block is such that he will never do that.
Because of consensus.
And so basically, when the block is collated, you can say, it's fine. And in that respect, because we also have a reliable external message protocol, which basically guarantees that once collator says it's okay, I'm including that in the block. You don't even need for the block itself. You get just enough for a collator to say, I'm fine, I will include it. I'm actually including that in the block right now. You can finalize. Of course, if you transfer like $1 billion, you would probably wait a few seconds for the master chain block just to be really completely sure. Right. But if you're transferring just few tons, believe me, you can have a finality of 200 milliseconds, basically.
Wow.
Yeah, I've literally done this in real life with some of my less savvy crypto friends, where you can get them to download the app, you touch phones together, and by the time you pulled your phone away, the transfer's done.
Exactly.
Again, to try and add a bit more of a basic kind of explanation for those people out there like me who struggle to keep up with giga geniuses like Mitja. The finality it's not actually as complicated as it sounds. I'd like to think of it like Monopoly. Everyone's played it. You have bank errors in your favor in that game. Unfortunately, in real life, most bank errors aren't in your favor. What all finality means
they're rankers,
all finality means is there can no longer be an error past said point. So the transaction can go through, but up until it's got finality, you can hypothetically still get that unfortunately, so you must give the money back. Exactly.
Like that is what I find very interesting in how Mitja puts it. It's that you can have finality within 200 milliseconds. Do we have examples or hypotheses where a longer finality has led to problems, or maybe in the real world?
It's just a user experience. And think of that also if you have a composability contract. You have some DeFi protocol and you run composable, I don't know what, you put some collateral against some loan, and then you put this loan as a collateral and go to some other loan and stuff like that. And then you go to DEX, you exchange something for something. Count transactions here. Think of that. And then okay, so how much time do you wait today to make all that happen? And also think of that as following. If you have a low scalability, and that's what Ethereum has, like then the gas price is just going parabolic.
As of today,
right?
Yeah.
Exactly. So, and here you have like you hit the button, boom, it's done, and then it costs nothing. What else? I mean, what else? What do you want?
I'll tell you what I want.
There we go. He's taking marketing tips in the background here, isn't he? He's Googling how to market.
Well, I will tell you like what I want, right? So Ethereum, because it is not so scalable, it gives me the opportunity to take out flash loans. I don't know how to take out one yet, but now I have this opportunity. Can you do that on Freeton?
No, because flash loans is a bug.
Flash loan
It's a
bug.
flash loan is a bug. Is a design bug in Ethereum. So you exploit some bug, and then you say, "How can you do that in a system that works correctly?"
Right.
Well,
right.
Well, you
I
can't.
agree. I totally agree.
But let me give you some good things
Right.
as well. Like you can do that by constructing a flash loan a smart contract.
Gotcha. That's
So, like,
interesting.
Yeah, you do it by design, man. I mean, come on, you want to give a flash loan, like do it by design. Just create a smart contract which has a guarantee of execution on certain conditions and give a loan. What's your problem?
I mean, there was all this stuff about the poly chain DeFi hack the other week, wasn't there? And again, I'm not wise in these ways, but if you look into the details, it's actually not as technically complex as as you would think to kind of work your way around these problems. It's an inherent kind of design flaw.
Yeah.
Yeah, bad designs leads to a security problem. What? How wondrous is that?
Right. No, it makes
Again,
sense.
we come back to the Mega Drive and why that never took off.
I'm sure some like marketer had to write a report where he had to present why it's such a good design, which is why it got made and sold. But yeah, coming back to this, Mitja. So when we talk about designs, right? So as Benjamin pointed out about this polychain hack or like poly network hack, how it was explained was that designers or technologists, programmers, they have this tendency to chop a problem into smaller bits. So they make it modular. One person builds this, one person builds that, and then it's the job of like one other person to make sure to build all of them into one machine. This taking these blocks and converting that into a bigger machine is where the problems arise, because they think that because all of them are doing good, the other part will also do good, but it doesn't work out like that. The article said 2 positives sometimes make a negative. What do you guys think about that? Like, what's your solution for that? Mitja, yeah.
Well, can you I didn't get it. Like, can you rephrase?
Of course,
shorter,
I'll give you.
Maybe.
Now it's my turn to give
what exactly
analogy.
do you mean?
Now it's my turn to give an analogy, right? Let's say that you are trying to build a car. So somebody builds the carburetor, somebody builds the engine, somebody builds the seat, and it is.
Well, it doesn't work like that. Here, on that point, it doesn't work like that, because before you build carburetor, before you build motor, there are designers who build the design of that thing, and then they build the specifications for that thing, and only according to the specification, someone can design an engine, a carburetor, whatever you want. And so if you didn't do the design correctly, you may miss that you need a carburetor in the first place.
Right.
I mean, the only part of the
and that's the whole point, right?
Was the design.
Yeah. On that happy note, though, I'd like to give it. I would like to call it a wrap. Thank you, Mitja. Thank you, Benjamin, and thank you, Pavel, for joining us. Let's do that like some other time when you have another milestone, or if you guys have an hour to spare. I would be happy to chat to you guys about this over and over again. Thank you for joining the HackerNoon Podcast.
It was a pleasure.
Yeah,
pleasure. Thank you very much.
Again, I could
Thank
talk
you
to you
for
all
inviting
day, Utsav, my friend. And
Yeah.
I hope you don't mind me giving a shout out, but obviously you've made a guest appearance on my very own podcast a couple of times. So, what's doing these things with our little cross promotion? If you're into cryptocurrency, check it out, starring Utsav and myself and lots of other fun, interesting people making jokes about the weird world of crypto. Thank you again, buddy.
Bye. Have a nice
good
one.
Bye.
HackerNoon Podcast.